Hello everyone. The title of this video is Solve Quadratic Inequalities Graphically. Each exercise I'm going to be doing in this video is taken directly from a free online textbook at openstacks.org, and it's their Intermediate Algebra 2nd edition text. I'll be working under the exercises in the heading Solve Quadratic Inequalities Graphically. I'll only be working on the even numbered exercises, right? The ones that don't have solutions, right? The odd numbered exercises, you can click on the number and you'll be taken to the solutions, right? So I'm not going to do those. So I'll be doing number 364, 366, 368, and 370, right? Just those four when we're asked to solve a quadratic inequality graphically. I will also have timestamps for these examples in the description of the video below. The example 1 timestamp will be for the beginning of 364, example 2 for 366, example 3 for 368, and example 4 for 370. I also request that when I start a new problem, that you pause the video and try to work on it yourself first, before watching me do it and comparing. Right? Because if you're just watching me do these things and not practicing yourself, chances are you're not learning all that much. Okay, so for each of the four exercises I'm going to do, we are asked to solve graphically the quadratic inequality, and part B, write the solution in interval notation, which you have seen, I'm assuming you've seen in my videos before, right, if you've been watching, or in your reading, wherever. I'm assuming you're familiar with interval notation. Alright, so number 1 I have written out. So example 1, exercise 364 from the text. We have x squared plus 4x minus 12, right, a quadratic polynomial, is less than 0. Alright, so here's how we're going to solve graphically. We're going to think of this expression, right? So first I take everything to one side, 0 on the other, which is already done, right? So I have a quadratic polynomial, ax squared plus bx plus c on one side and 0 on the other side. And then we think of this expression as a function, right? Think of it as a function of, in this case, the variable is x. So I'm going to call this x squared plus 4x minus 12 the function f of x. And now we're going to look at the graph of this function. Graph f of x equals x squared plus 4x minus 12. Right. The way I would normally graph any quadratic polynomial function or any parabola. So notice it's in that form that I like, the standard quadratic form, or y equals or f of x equals ax squared plus bx plus c, where a is the quadratic coefficient, positive 1, b is the linear coefficient, positive 4, and c is the constant term, negative 12. Okay, so looking at the lead coefficient is positive. So the graph of this quadratic function, right, this parabola, is going to be a parabola that opens up. Right, it's going to be like a smiley face. Right, so its vertex will be the lowest point on the graph, right, and every other point will be above the vertex. So let's find that vertex. Now I'm going to tell you right now, the key to solving a quadratic inequality, the key will be finding the x-intercepts. We'll get to that in a second. And you've seen me finding x-intercepts of graphs before in previous videos. But the key to solving these will be finding the x-intercepts, I promise you. Alright, so going through the usual steps, graphing a parabola. First I'm going to put down the axis of symmetry, right, that vertical line that will cut the parabola in half, right, run through the vertex. And the axis of symmetry I'm going to be abbreviating just AOS for the rest of the video. And hopefully you recall the formula for this, right? This is something I'm assuming you've memorized. X equals the opposite of b divided by 2 times a, where you have y equals ax squared plus bx plus c, right? It's got to be in that particular form. Alright, so the opposite of b is negative 4. 2 times a is 2 times 1, that's just 2. So x equals negative 2, right, is the axis of symmetry, and I'm going to highlight that in a graph. Here's x, and then here's f of x or y, same thing, right, the outputs. And x equals negative 2, right, there's negative 2 on the x-axis. And I'll make a little dotted vertical line. Right, this is not actually part of the graph, right, it's just the axis of symmetry, right, x equals negative 2. The vertex, right, will be on this line. Alright, so next I usually went on and found the vertex. Right. The vertex has an x-coordinate of negative 2, right? It should be on the axis of symmetry. And then what is f of negative 2? Right, so what's the output when I plug negative 2 into this function, x squared plus 4x minus 12? Well, negative 2 squared, I'm just going to say it out loud. Negative 2 squared is positive 4. 4 times negative 2 is negative 8. 4 plus negative 8 is negative 4. Minus 12 is negative 16. Right, negative 16. Alright, so I'm just going to do this on my graph here. Say this on the y-axis. Say this is 4 units, and then 8. So negative 8, negative 12, negative 16. And the vertex, right, of this parabola is all the way down here. So at this point right here. And since we know this is going to open up, it is going to hit the x-axis, right? This parabola will have x-intercepts, and now I will find those. Now, you can do just all the intercepts, x-intercepts and y-intercepts, which I'll do. Why not? Now the y-intercept is easy. Right, you just put in 0 for x, and you'd get negative 12 for y in this function. Right, so here's the y-intercept. 0, negative 12. And you could use the symmetry to find another point. That 0, negative 12 is 2 units to the right of the axis of symmetry. So if I go 2 units to the left, I'll also get an output of negative 12. So negative 4, negative 12, right, would also be on this parabola. And now for the x-intercepts. Right, now remember, the x-intercepts are when the output is 0. Right, so when you're solving this equation, when is y equal to 0? When is f of x equal to 0? So that's when is x squared plus 4x minus 12 equal to 0. And you could use the quadratic formula, solve by completing the square, or factoring if possible, which for this one it is possible, right? This factors to x plus 6 times x minus 2 equals 0. And so that, negative 6 is a solution, so one of the x-intercepts is negative 6, 0. And positive 2 is another solution. Right? So another x-intercept is positive 2, 0. Right? So I'll plot those points. So there's negative 6 on the x-axis and positive 2. And there's where the x-intercepts are going to be. And once again, the x-intercepts are going to be key in determining the solutions of a quadratic inequality. And then positive 2. Right? So now let me graph this. Right? Make a graph. Now we have enough points here to make a graph of this polynomial function, this quadratic function, this parabola. Just, the lowest point is the vertex. Again, please don't make it pointy, right? It's curvy at the vertex and then going up here through the x-intercept, upward forever that way. And then same thing on this side, going up here through the x-intercept and up forever that way. All right. Now we can use our graph to find the solutions of this inequality. All right, this inequality is basically, where is f of x? All right, where is this x squared plus 4x minus 12? Where is it less than 0? Pardon me. Or where are the y coordinates less than 0? Well, if you look at our graph here and then focus on the x-axis, see over here, for values of x greater than 2, f of x is positive. See, the graph is above the x-axis. The y values are positive. So these values to the right of 2 are not solutions of this inequality. We want to find the values of x that make the left side, that make f of x less than 0, not greater than 0. All right. And for these values here, between the x-intercepts, from negative 6 to positive 2, the value of the function, the y values, are less than 0. You see the graph between negative 6 and positive 2, the graph is below the x-axis. So the value of the function is less than 0. The value of this expression is less than 0. So these numbers, from negative 6 to 2, right, between them, are solutions. They satisfy this inequality. They make x squared plus 4x minus 12 less than 0. Right, and then all the numbers on the other side of negative 6, right, all the numbers to the left of negative 6, all these numbers here, you see when I plug these in, the function is above the x-axis as a positive output. The value of f of x is greater than 0. So the only numbers that are solutions here the solutions of this inequality are values of x between negative 6 and positive 2. Right. So I'm going to put that in a box, right? Now notice I didn't include negative 6 or positive 2, because negative 6, right, at negative 6 exactly, f of x equals 0. Right? It's on the x-axis, the graph. And same thing at positive 2, f of x equals 0. Right? It's not less than 0. It's equal to 0. So the only values of x that make this expression less than 0, that satisfy this inequality, are between negative 6 and 2, right, where the graph is below the x-axis. I hope that's clear. So there's one way to state the solutions, right, as a compound inequality. That's part one, solve graphically. The other part was write the solution in interval notation. So the interval for this particular set of numbers, right, is again going on the x-axis here from left to right, low to high. The solutions are from -6 to 2, so -6, comma 2, and then remember you cap these off with either a bracket or parentheses. Bracket if the number is a solution, parentheses if it's not. Well, -6 we saw is not a solution, so parentheses on that. +2 is not a solution, so parentheses on that as well. And there's your set of solutions in interval notation as well. It's all the numbers between -6 and 2, but not including -6 nor -2, or nor +2. Great. But yeah, so again, the key is going to be the x-intercepts. All right. You graph it, graph your parabola. First, you're going to take everything to one side, 0 on the other. Get, ax squared plus bx plus c is less than or greater than or less than or equal to or greater than or equal to 0. Then you're going to think of that quadratic polynomial as a function, graph that function, graph the parabola, and see where is it above the x-axis, where is it greater than 0, where is it below the x-axis, right? Where is the output, where is the function less than 0, and you can see your solutions very easily in the picture. All right, so let's do that again. All right, so question 2 here, exercise 366 from the text. It's already set up the way I want. And I've got ax squared plus bx plus c on one side and 0 on the other. And we're trying to find the values of x that make x squared minus 6x plus 8 greater than 0 or equal to 0 this time. Right? The or equal to part is also there. All right, so once again, I'm going to think of this quadratic polynomial over here as a function. And I'll call it f of x again. You can call it whatever you want, but I'm going to call it f of x. You can call it g of x, h of x, y, whatever. So now let's graph y equals, or f of x equals, sorry, I called it f of x. F of x equals x squared minus 6x plus 8. Alright, so the axis of symmetry, now we know it's going to open up, right, because the lead coefficient is positive. This is going to open up. It would be a smiley face. The axis of symmetry will be x equals the opposite of the linear coefficient. Now b is -6 here, so it's +6 in the numerator, divided by 2a, 2 times 1. Right? So x equals 3 is the axis of symmetry. Right? The vertex will have an x value of 3, and then you got 3 squared is 9, minus 6 times 3 is 18, 9 minus 18 is -9, plus 8 is -1. Alright, so the vertex, I'll plot. I'm not going to draw the axis of symmetry this time. Right. Is at 3, right? Input 3, output -1. Right. So there's the vertex, 3, -1, and it opens up, so I know the parabola is going to have x-intercepts, which is what I'll find next, the intercepts. Now the y-intercept, easy, right? 0, 8. Input 0, output 8. And if 0, 8 is on the graph, so will 6, 8, right? Using the symmetry around x equals 3. So 6, 8 would also be on the graph. Right, and now we need the x-intercepts though. The x-intercepts, as I said in number 1, are key to finding the solutions of a quadratic inequality. Right, so for the x-intercepts, we're solving this equation. Where is x squared minus 6x plus 8? equal to 0. Again, you can use the quadratic formula, completing the square method, or factoring, and this is another factorable polynomial. Factors to x minus 4 times x minus 2. Alright, so the x-intercepts, one solution is 4, the other solution is positive 2. So 4, 0, and 2, 0 are the x-intercepts. So 1 unit to the right of the axis of symmetry and 1 unit to the left. 4, 0, and 2, 0. And then I make a graph. Just make sure it's not pointy, right? And got this parabola here. Right? It's not perfect looking, but passing through that that y-intercept there and that point there. Cool. All right, but it opens up. All right, and we're seeing that over here, right, over in this area, to the right of 4, the value of this function is positive, right? The graph is above the x-axis. Same thing over here, right? To the left of 2, the value of the function is positive. So those are solutions, right? We're looking for where is this function greater than 0, positive or equal to 0. Right? In between, right, in here, in between 2 and 4, the value of the function is negative. And then at 2 and at 4, at x equals 2, the value of the function equals 0. At x equals 4, the value of the function equals 0. So we can very easily see our solutions. Right, the solutions to this inequality, all the values less than 2 make the output positive, right? Satisfy this, they have this expression be greater than 0. Also 2 itself. So values of x less than or equal to 2 satisfy, or, because there's a separation here, the values between 2 and 4 don't make it true. They make the value less than 0. They don't make it greater than 0 or equal to 0. But then all these values over here to the right of 4, and including 4, right? The ones to the right of 4 make the output greater than 0, and 4 itself makes the output equal 0. So, or x is greater than or equal to 4. Right, so there's a way to state the solutions using inequalities. And then we could also state in interval notation. Right, the interval for x is less than or equal to 2 is everything from negative infinity up to 2, including 2, right? So a bracket on 2, and then you always have parentheses on infinity or negative infinity, right? Those are not numbers. And then for the gap, union symbol, right, represents the word or. And then the interval for x is greater than or equal to 4 is, from 4 to infinity. But 4 is a solution this time, right? It satisfies the equal part. So bracket on 4 and parentheses on infinity. And there we go. 2 different ways of saying the same set of numbers, right? All the numbers that will make my inequality a true statement. Fantastic. Great. All right, I'm doing the same thing for all 4 exercises. Next question. So same deal. Now it's already the way I want it. Everything on one side, 0 on the other. And it's in that ax squared plus bx plus c form already. So I'm going to think of this quadratic polynomial as a function. So again, I'm going to call it f of x, right? You can use whatever you want, call it something else. But I'm just going to call it f of x. So now we're going to graph the function f of x equals negative x squared plus 2x plus 24. Now, because the lead coefficient is negative, I know that this is going to be a parabola that opens down, right? Frowny face. The vertex will be the highest point. The axis of symmetry will be x equals, negative 2, the opposite of b, divided by 2 times a, which is also negative 2. The axis of symmetry will be at x equals 1. Alright, then the vertex will have an x coordinate of 1, and when I plug in 1 you get 25. Right, that'd be negative 1 plus 2, which would be positive 1 plus 24. Alright, so I'm going to draw a little picture over here. So x equals 1, and then we'll go every 5 units up to x-axis, and then the y-axis, or the f of x-axis, whatever. I'll have these notches be every 5 units. So 20, 25. Alright, so 125 is the vertex. So the vertex is above the x-axis, and we know it opens down. So if it opens down, it's definitely going to hit the x-axis. It's going to have x-intercepts. And those will be key to stating the solutions of the inequality. The intercepts, the y-intercept is the easiest always, right? It's 0, 24. Right, so let's say that's here. Just a little under 25 here. And if 0, 24 is on there, using symmetry, 2, 24 would also be on the parabola. Okay. Alright, and now the x-intercepts, right? These are key. These are the most important ones for enabling us to find the solutions of the inequality. We're solving this equation. Where is the function, negative x squared plus 2x plus 24? Where is this equal to 0? Alright, again, you can use the quadratic formula, complete the square method. Once again, if I multiply by a negative, get positive x squared, multiply both sides by negative 1. We have x squared minus 2x minus 24 equals 0. And we have another factorable polynomial. This factors to x minus 6 times x plus 4. Alright, so the solutions are positive 6 and negative 4 here. So the x-intercepts are at 6, 0 and negative 4, 0. Right. And so 5 units to the right of the middle, 5 units to the left of the middle. So 6, 0, negative 4, 0. Alright, now that I have the intercepts in and a bunch of points on either side, I can make a rough sketch of the graph here. This parabola opening down. Okay, great. Alright, and now what we're looking for are values of x that make this expression less than 0, which would be below the x-axis. And that would be these values here, right, to the left of negative 4. See, f of x is less than 0 here. The graph is below the x-axis. Or these values over here. F of x is less than 0, right? The graph is below the x-axis. In between, the value is greater than 0. Right, but we want ones that make it less than 0. And negative 4 makes it equal to 0, so that's not a solution. Positive 6 makes it equal 0, so that's not a solution. So the only solutions, the solutions are the values of x less than negative 4, or, because there's a gap, or, and then values of x greater than 6. And there's one way to describe them with inequalities. And I can write this in interval notation as well, right? They are asking us to write the solution set in interval notation. So x is less than negative 4, that's negative infinity up to negative 4, but not including negative 4, so I got parentheses on that. Then there's a gap, right? Union for the gap, union for or. And then x values greater than 6, that's from 6 to positive infinity, but not including 6. So again, parentheses on those. And there's another way of describing the same set. Right? These represent the same numbers, the same solutions. Numbers that when I plug them into the inequality would make the inequality a true statement. Wonderful. Okay. And then finally, one more here that we're asked to solve graphically. So negative x squared plus 2x plus 15 is greater than 0. So again, we have a quadratic polynomial in the form that I like, ax squared plus bx plus c on one side and 0 on the other. And so once again, I think of this quadratic polynomial as a function. Once again, I will just call it f of x and we'll graph it. Graph that quadratic function. F of x equals negative x squared plus 2x plus 15. So once again, I notice the lead coefficient is negative. So this parabola, when I'm done graphing it, will be opening down. Right? The vertex will be the highest point. We can now find the axis of symmetry pretty easily. It's x equals the opposite of the linear coefficient, so negative 2, divided by 2 times a, which is negative 2 again. So x equals 1 again. And then the vertex will have that as an x-coordinate. And if I plug in 1, you get 16. Right? Negative 1 plus 2 is 1, plus 15 is 16. Right, so I'll start graphing this. So x-axis, and then y-axis, or f-axis. I got 1, and then I'll just go every 4 on the y-axis here. 4, 8, 12, 16. So 116 is the vertex that's on this parabola here. And it's opening down. So if this is opening down, it's again going to definitely hit the x-axis. It's going to have x-intercepts. Let's find the intercepts. Y-intercept is the easy one, right? That would be 0, 15. So let's say that's here, 0, 15. And if 0, 15 is on the graph, so is 2, 15. Right, input 2, output 15, using the symmetry. Okay, and now the key values, the most important ones here for solving our inequality, the x-intercepts. So I'm just determining where the function is equal to 0, right, where the output 0, where is negative x squared plus 2x plus 15. Where is that equal to 0? Again, I can multiply both sides by negative 1. We have x squared minus 2x minus 15 equals 0. You can use the quadratic formula, completing the square. But once again, we have a factorable polynomial. This factors to x minus 5 times x plus 3. So the solutions are positive 5 and negative 3, right? So the x-intercepts are at 5, 0, and negative 3, 0. Right, 4 units to the right of the axis of symmetry and 4 units to the left. So there's one x-intercept, there's the other. And I'll make a rough sketch of the graph. All right. Now this time, pardon me, we're looking for values of x, values on the x-axis that make this expression greater than 0. Have positive outputs, and that would be in between negative 3 and positive 5. It's here where f of x is positive, right? To the left of negative 3, those values give me a negative output, less than 0. right, to the right of 5. Those values give me a negative output, less than 0. Negative 3 gives me an output equal to 0, so that's not a solution, that's not greater than 0. And positive 5 also gives me an output equal to 0, not greater than 0. So the only numbers that are solutions are between negative 3 and positive 5. So the solutions of this inequality are values of x between negative 3 and positive 5, but not including them, right? Negative 3 and 5 are not themselves solutions. All right, and then interval notation for this. The interval for this same set, it'll just be values from negative 3 to 5, so negative 3 comma 5, but not including them, right? Negative 3 has parentheses and 5 has parentheses, because they're not actually solutions, but every number in between them is. And you could test that out, pick any number you want between negative 3 and 5, say negative 2, negative 1, 0, 1, 2, 3, 4, 1.5, pi, square root of 2. Plug it into the expression up here, and this inequality will be a true statement, I promise you that. But I leave it to you to check that. All right, wonderful. So that's it. That's how you solve a quadratic inequality graphically. You get ax squared plus bx plus c on one side, 0 on the other. Graph that polynomial function, and then just see, which values of x make that polynomial have positive outputs, greater than 0, or negative outputs less than 0, or, equal to 0, where you're on the x-axis. But the key values you need, though, are the x-intercepts. Those are key. Those are super important to solving these, as you've seen. Great. All right, so I'm hoping that watching me go through these 4 examples here help you in some way, when you're asked to solve a quadratic inequality graphically on your own. And thank you very much for watching.